Hello students. Now in the last lecture we discuss progressive wave, its properties, and we find out the general equation of progressive wave. Right? Now today we discuss a new article and name of this article is reflection of wave. Reflection of wave. Right? Now we know that when one wave, when it is traveling from one medium to the other medium, at that time between these two medium, now there is boundary, right? Now due to this boundary, this wave is reflected. Now we have to study how these waves are reflected, right? Now today we discuss this article, reflection of wave, right? But when we have to study this reflection of any wave, at that time minimum two mediums are required, right? Now in this case we consider two medium, first medium and other is second medium, right? Now between these two medium, now there is a boundary. This is the boundary between these two medium, right? Now when we have to study reflection of any wave, at that time we consider two types of medium. Now we consider one medium, it is known as a rarer medium, and the other medium is known as a denser medium. Therefore, while we consider reflection of any wave, at that time we consider one medium is rarer medium and the other medium is a denser medium, right? Now, between any two medium, now there is boundary between these two mediums, right? Now, first we consider one progressive wave. This wave is traveling through any one medium. Now, this wave is known as the incident wave. Now, this wave is traveling through that medium and it incident on this boundary, right? Now, we consider here. Now, we consider first wave. This wave is traveling and this wave is traveling through the first medium, and this wave suppose is known as a incident wave. This wave is known as a incident wave. Now this wave is traveling through the first medium and this wave incident on this boundary between these two mediums, right? Now when any wave incident on a boundary in between two medium, at that time there are three possibilities are there. What is the first possibility? This wave may be reflected. The first possibility is the reflection of that wave. Second, now some part of this wave can be absorbed by this boundary. Second is absorption. Second is absorption. And again, when some remaining part of this wave can also be transmitted from this boundary to the second medium. Therefore, the third is transmission. Third is transmission or refraction. Transmission or refraction. Therefore, when any wave travels through any one medium and when it reaches towards the boundary between two mediums, at that time there are three possibilities are there. One is this incident wave can be reflected, or this incident wave can be absorbed, or incident wave can be transmitted or refracted from this second medium, refracted towards the second medium. Okay. Now we consider one by one what happens. Now suppose initially this wave is traveling, first wave is traveling to the first medium and this wave is the incident wave. Now this incident wave reach or incident on this boundary, right? Now initially when as soon as this wave incident on this boundary between two medium, at that time some part of this wave now get reflected in the same medium. This part of wave get reflected back through the same medium in this way. Right? Now this wave is a reflected wave. This wave is known as a reflected wave. Right? Now again some part of this incident wave is remaining. Again some part of this wave can be absorbed by this boundary, right? Again, some part of this incident wave is remaining. Now, this remaining part of this incident wave can cross this boundary and can travel through the second medium. And when it travels through the second medium, at that time, suppose this is the wave which travels through the second medium, right? Now, this wave is known as a refracted wave. This wave is known as a refracted wave, or it is also known as a transmitted wave, right? In this way, when any wave is incident on this boundary between any two medium, at that time some part of wave can be reflected, some part of wave can be absorbed, as well as some part of wave can be refracted or transmitted from this towards this second medium, right? In this way, we have to consider reflection of wave, absorption of wave, as well as refraction of wave. But these two, absorption and refractions, now we do not consider. We only consider the reflection of wave. Therefore, today we discuss this reflection of wave. Okay. Now, in this reflection of wave, now we have to consider two types of waves. We have to consider two types of wave. One is transverse wave, and second is longitudinal wave. Right? Therefore, we have to study here reflection of transverse wave as well as reflection of longitudinal wave. Now we study one by one. Now first we consider reflection of transverse wave. Therefore, in this case, we only consider the transverse wave, right? So, now this transverse waves can be again classified into two parts. Now, this reflection of transverse wave can be due to this rare medium as well as due to this denser medium. Now, we consider first part. Reflection of transverse wave from denser medium. Okay. Now we consider one long flexible string, and one end of this string is fixed with the help of the rigid support. Right? Now, when this free end of the string is held in your hand, and when it is moved up and down, at that time a crust is formed. Now this crust is formed at this free end, and this crust is traveling along this string. Now this crust is traveling along this string, right? Now this crust is traveling, at that time the number of particles, the crust pulls the number of particles of the string vertically in upward direction, and due to motion of this particle, now crust travels from the free end to the fixed end. Now this crust is traveling. Now the crust reaches to the fixed end. Now this is the crust, and this is the velocity of this crust, right? Okay. Now as soon as this crust reach to the rigid support or to the denser medium, now you consider this is denser medium and this is rarer medium. Okay. Now as this crust reaches towards the denser medium or with the rigid support, at that time when this crust incident on this rigid support, at that time this crust try to pull the particles of denser medium vertically in upward direction. But as this denser medium or this rigid support is at rest, because no sufficient energy is provided by this crust on this rigid support or a denser medium. And as there is no sufficient energy, now this denser medium or this rigid support remains at rest. Therefore, according to Newton's third law of motion, now action and reactions are equal and opposite. Therefore, no action is produced on this denser medium, and when there is no action is produced, but this denser medium produces one reaction on this crest, and due to this reaction of this denser medium or this rigid support on this crest, now this crust is reflected back. This crust is reflected back as trough. This crust is reflected back as trough, and this trough is moving in this direction. This is reflected as trough. Now this is the rigid support, right? Now as this crust incident on this rigid support, now this rigid support produces a reaction on this crust, and due to this reaction, this crust is reflected back as a trough, and again this wave is moving in the same medium. Therefore, this wave is incident wave. This wave is an incident wave, and this wave is a reflected wave. This wave is a reflected wave, right? Therefore, we observe that when transverse waves traveling through the rare medium and when it incident on this denser medium, at that time we observe that crust get reflected back. Crust get reflected back in the same medium, reflected back in the same medium. At the same time, therefore we observe that crust is reflected back as a trough. At the same time, when there is trough, now this trough is also reflected back as a crust, right? Therefore, at the same time, when this crust is reflected back as a trough, at that time, now phase angle changes. Phase angle changes. Now, therefore, this phase changes. Phase changes by pi radius. Phase changes by pi radius. Okay. Now, in this way, in the first part we consider here reflection of transverse wave from denser medium. Means when transverse wave travels through the rare medium and when it is incident on this denser medium, at that time this crust is reflected as trough, and this trough is reflected as crust, and at the same time phase changes by pi radius. Okay. Now in this way we study reflection of transverse wave from a denser medium. Now again we have to consider the second part. Now in the second part again we have to consider here reflection of transverse wave from rarer medium. From rarer medium. Okay. Now in this case we consider again two mediums. One is rarer medium and other is denser medium. Now in this case again we consider one thread. Now at the fixed end, at the one end of this thread, one ring, light weighted ring is taken, and this string or this ring is placed in a rod. Other end of this thread or string is free, right? Now when this free end of this string is moved up and down rapidly, at that time crust is produced at its free end. Now we draw here, crust is produced, and this crust is traveling along this string towards the ring. Okay. Now when this crust is traveling, at that time the crust try to pull all the particles of that medium vertically in upward direction. Now in this way this crust travels and it reaches to the other end. At that time this crust which reach to the other end. Now when it reaches near this ring, which is light ring, right? Near this ring, at that time what happens? This crust try to move this ring vertically in upward direction. Now as this ring is not a fixed, now it is free to move. Now when this crust try to move this ring vertically in upward direction, now this ring can easily move vertically in upward direction, right? Therefore no reaction is produced on this crust. No reaction is produced on this crust by this ring. Therefore this crust is reflected as crust. Therefore in this case this crust is reflected as crust, and again it returns back in the same medium. Crust is reflected as crust. Right? Now, in this way, this wave is an incident wave. This wave is an incident wave, and this wave is a reflected wave. This wave is a reflected wave. Okay. Now, again, we observe that when transverse travel from one medium to the other medium, and when it reaches to the rarer medium, at that time when it is incident on this rarer medium, at that time now sufficient energy is provided by this crust, and due to the sufficient energy, ring can easily move vertically in upward direction. Therefore, according to Newton's law of third law of motion, at that time action and reactions are equal and opposite. Therefore, no reaction is produced by this ring on this crust. Therefore, ring can easily move vertically in upward direction. Therefore, this crust is reflected back as a crust. And when we consider here, crust is reflected as crust, and when there is trough, trough is reflected as trough. Right? When, when it happens, at that time we observe that there is no phase change. Therefore, again we write here, there is no phase changes. No phase change. Right? Now, in this way, we consider second part. Now, reflection of transverse wave from denser medium means when transverse wave travels and when it is incident on this rare medium, at that time, at this rare medium, now this crust is reflected as crust and trough is reflected as trough, and at that situation there is no phase change, means phase does not changes. Okay, now this is the second part of this this is the reflection of transverse wave, right? Now again we consider reflection of wave from thin string to thick string. Thin string to thick string. Now again in this case we consider two strings. Now we consider, suppose this is a string. Now this string is a thin string, or it is also known as a light string. Light string. Again we consider another string. Now this is thick string or a heavy string. Now we consider two types of string, thin string or thick string, right? Now at that time we have to consider here reflection of wave from thin string to thick string. Now when this wave is traveling from this thin string and when it reaches or incident on this thick string, at that time what happens? At the same time, again we have to consider here when this wave traveling from thick string and when it is incident on this thin string, at that time what happens? Now we consider one by one. Therefore, in that case, this is reflection of wave from thin string to thick string. Right? Now we consider thin string, and this thin string is connected to a thick string. Therefore, it is thin string and this is thick string. Okay. Now, this free end of this thin string, when this free end of this thin string is moved vertically up and down, at that time crust is produced, and this crust is traveling from free end to the fixed end. Right. Now again, thick string is connected. Now as this crust is traveling continuously, at that time each and every particle of that wave of the string vibrates vertically in upward direction. Therefore this crust travel from this point to this point. Now this crust reaches near the boundary junction. Near this boundary junction, right? Now, as soon as this crust reaches near this boundary junction, at that time, now this crust acts on these particles of thick medium. This crust try to move this thick medium particle vertically in upward direction. Vertically in upward direction. But as this thick particle is a denser medium, at that time it does not produce a sufficient energy so that these denser medium particles can move vertically in upward direction, right? But according to Newton's third law of motion, now action and reactions are produced. Now there is no action produced by this crust on this denser medium, but reaction is produced by this denser medium on this crust, and due to this reaction which is produced by this thick string on this crust, now this crust is get reflected back as a trough. Therefore, it is reflected as a trough, and again it moves along the same medium, right? Now it is reflected as trough. This wave is moving, right? Now this wave is incident wave. This wave is a incident wave, and this wave is reflected wave. This wave is reflected wave, right? Now, at the same time, when this crust incident on this thick string, at that time, now this thick string produces a reaction on this crust, and this crust is reflected back in that medium as a trough. But at the same time, some part of this incident wave now get transmitted through that denser medium or thick string, right? And due to this transmitted part of incident wave, now a crust is produced in this denser medium. A crust is produced in this denser medium, and this crust is traveling through that denser medium, right? Therefore, at that time, this is the transmitted wave. This is the transmitted wave, right? Therefore, from this it is observed that when transverse wave traveling through the thin medium, and when it is incident on a thick medium or a denser medium, at that time, now this crust is get reflected as trough. Crust is get reflected as trough, and at the same time, when this trough is moving towards the denser medium or thick string, at that time this trough is get reflected back as crust, right? And when it happens, at that time phase changes. Phase changes by pi radians. Phase changes by pi radians, right? In this way, we study reflection of wave from thin string to thick string. Now we consider first thin string disconnected with thick string. Now when wave is traveling from thin string and when it incident on this thick string, at that time we observe that crust get reflected back as trough, and trough get reflected back as crust, and at the same time phase changes by pi radians. Okay. Now come to the second part. Now in this next part, now again we have to consider here reflection of wave from thick string to thin string. Thick string to thin string. Okay. Now in this case we consider a thick string first, and it is connected to the thin string. Therefore it is thick string and this is thin string, right? Now when one end at the free end of this thick string, when it is moved up and down rapidly, crust is produced at its free end. Now we draw this. Crust is produced and this crust is moving along this string, right? Now, as this crust is produced at its free end, now this crust try to pull all the particles of that medium vertically in upward direction. Now, it can easily pull all these particles vertically in upward direction. Therefore, this crust travel from free end to this junction or boundary, right? Now, as soon as this crust reaches near this boundary, at that time this crust try, and this crust is from a thick medium means it is a denser medium, and this other string is a thin medium, right? Now therefore this crust when reaches towards the thin medium, at that time this crust try to pull all these particles, thin medium particles, to push or pull in vertically upward direction. Now, according to Newton's third law of motion, now this crust has sufficient energy to pull the number of particles of this thin medium vertically in upward direction. Now, it is possible. Therefore, according to Newton's law of motion, now no reaction is produced by this thin string on this thick string crust. Therefore, on this crust, reaction is not produced by this thin medium. And when reaction is not produced at that time, now this crust is get reflected back as a crust. Now, therefore, after reflection, crust is reflected as a crust and it is moving along the same wire. Therefore, this wave is an incident wave. This wave is a incident wave, and after reflection, now this wave is a reflected wave. Wave is a reflected wave, right? But when this crust reaches to this junction point, at that time now no reaction is produced by this thin string on this crest. Therefore, this crust is reflected back as crust, right? But at the same time, some part of this incident wave can transmitted in this thin medium, and due to this remaining part, now this thin medium, or in this thin medium, this string, now another compression is produced, and when this compression is traveling through that medium, at that time it is transmitted wave. It produces transmitted wave, right? In this way, we observe that when any wave which is traveling through a thick string, and when it reaches to the thin string, at that time crust is reflected as crust. Crust is reflected back as crust, and when trough is reaches or incident on this thin string, at that time this trough is reflected as trough, and at that time we observe that there is no phase changes. There is no phase change. There is no phase change. Right? In this way, today we discuss reflection of transverse flow. Reflection of transverse flow. In that case, we consider reflection of transverse flow from denser medium. Then we observe reflection of transverse flow from rarer medium. And again we consider reflection of waves from thin string to thick string, as well as reflection of wave from thick string to thin string. Okay. Now today I give you some assignment. Please solve this assignment and bring in the next lecture. Okay. Now write down this assignment. Now the first question, define progressive wave. Define progressive wave. State any four properties. State any four properties of progressive wave. Any four properties of progressive wave. Okay. Now this is the first assignment. Define progressive wave. State any four properties of progressive wave. Okay. Second, distinguish between transverse wave and longitudinal wave. Transverse wave and longitudinal wave. Okay. In this way, we have to solve two questions. First is define progressive wave, state any four properties of progressive wave, and second is distinguish between transverse wave and longitudinal wave. Okay, thank you.